part 2 for G4. So G4, and then there's going to be another part of it. We're going to use our properties. So we want to write this out in expanded form. And anytime you're on a quiz for me and you get stuck and can't remember the rules, write it out in expanded form. If we are looking at it, so the reason we're going to do expanded is because we want to try and get a shortcut that would help us. So m to the 4th, if I am looking at it, Sam, how many m's you write down? 4 of them. And then Patrick, for m to the 2nd, I'm writing down how many of them? 2 of them. So if I am writing all these out, and I want everyone to write it in expanded form because we want to be thinking, this is how many m's, Jordan, as I'm looking at that? 6 of them. I get m to the 6th. Here, we have y to the -1 and 3. Now, I don't like this one as much as an example, because what have we said to do with our negative exponents? Put them down in the denominator. So, if we're looking at this, this is going to be y to the 3rd, right? And in our numerator, we're now going to have y to the 1. What does y to the 3rd look like, Ashley? How many y's? Expanded form. 3. And Luden, y to the 1st is just 1y. So Luden, as we're looking at that, is there anything you can see that you can cancel or simplify? Y divided by y. And we are left with this being equal to y to the 2nd. So this one is equal to m to the 6th. This one is equal to y to the 2nd. And it says, you know, if I was looking at these problems and I didn't write it out in expanded form, like some of you on that homework quiz when you wrote out 17 x's and 12 x's, I want to use a shortcut. What would you think if I'm looking at this, my shortcut might be, Levi, that I'm doing with these two numbers?
Oh, you're adding?
We are adding them. So I kind of gave it as I was saying it. But so as we look at that, what are we doing with our exponents? What we want to write down, the shortcut, is when the base is the same, we add the exponents. So we add the exponents when you multiply with the same base, and that is huge. With the same base. If one's an x and one's a y, you can't add the exponents. You can only do it when you have exactly the same base. Okay? Questions at all?
Let's take a look at the product of powers rule. To do this, let's start off by looking at an example. Let's perform a multiplication, and we'll throw in some exponents while we're at it. Let's say that we have 4 squared, and we want to multiply that by 4 to the 4th. So we're taking 4 and squaring it, and multiplying it by 4 to the 4th power. Now in order to simplify this problem, let's expand everything out. 4 squared is the same as taking 4 times 4. And 4 raised to the 4th power is the same as multiplying 4 together 4 times. Remember, exponents are just repeated multiplication. The exponent keeps track of how many times you need to multiply that base together. So here we have an exponent of 4, which means we're going to multiply our base together 4 times. So our base of 4 is multiplied together 4 times. Now look, we're taking 4 and multiplying it together 6 times. So we could rewrite this as 4 to the 6th.
Please write that in your notes.
That means that 4 squared times 4 to the 4th is equal to 4 to the 6th. Now take a look at this. Let's say again that we have 4 squared times 4 to the 4th. You know, if we look at these exponents, 2 plus 4 is 6. So here, what if we rewrote it like this? Having that base of 4 and just taking those exponents and adding them together. So here, 2 plus 4 is 6. And we get 4 to the 6th again, just like we got when we expanded everything out. I wonder if this can work for other examples. In fact, it can. Here, we actually use the product of powers rule to simplify. So let's take a look at that rule. The product of powers rule states that for any number a, and for any numbers n and m, if we have a raised to the n power times a raised to the n power, that's the same thing as a raised to the n plus n power. So here we would take things that have the same base and add their exponents together in order to simplify. Now, in order to use the product of powers rule, we must have like bases. So this base must be the same as this base. If they're different, we cannot use this rule. Now that we've seen the product of powers rule, let's take another example. Here, let's work with some variables. Because yes, the product of powers also works with variables. Let's say that we have x to the third and we're multiplying x to the fifth. Here, let's expand this out to see what's going on. X to the third is the same as x times x times x.
What are we doing with our exponents? We want to be filling in here that what we do with our exponents is we want to add them. I think most of you already put down your answer for this first one when we had 4 to the second and 4 to the fourth. And I am amazed that some of you, when we get to the quiz or a test on this, will tell me this answer, 16 to the 6th. You like to multiply these two. You can't do that. It stays the same. It is not a 16. This one is going to be a to the m plus n. And the last one, if we are adding those together, is going to give us x to the 8. Now, do you need to show me the adding 3 plus 5 or the adding 4 plus 2 in your problems? No. But sometimes you get a lot of variables and a lot of different things going on. Then I might have you show. And especially if you're getting these wrong, right? If you're making mistakes, then I'm going to be pickier on you to show your work. So, as we take a look at the first one, do we have the same base? Yes. Please write down your answer. Be ready if I call on you as we're looking at our notes on the top of page 11. So, we are going to end up with 7 to the, what would you have as we look at it, Joe? 7 to the 7th. Okay? Now, if it says leave your answer as a power, this is a power. So on that first quiz, some of you tried to multiply all those 7s out or all the 4s out. When it says leave your answer as a power, that means I want a base and I want an exponent. Okay? So I look at this one. I have all these negative 6s, right? So I am going to be taking my negative 6, keeping the parenthesis. Do not get rid of your parenthesis. And as I look at those, Matt, what should I be adding? 12 plus 5 plus 2, right? So if I'm adding those together, Caitlin, I'm going to end up with, so negative 6 to the 19th power, and we're going to leave it like that, okay? We're going to keep that parenthesis. Parenthesis, the number goes outside the parenthesis. But if I take a negative number to an odd power, what would this answer be? Positive or negative at the end? From yesterday. Should be negative, right? Negative base to an odd power, anytime it's in that parenthesis, is always going to give us a negative answer. We didn't have to compute that. As we take a look at the next one, here's where I have people start making some mistakes. So, Nolan, we're going to add those together, right? And we're going to end up with 24 to what power? 24 to the negative 2. Now, notice the parenthesis was around the outside of the 24 to show us that. So do I really need the parenthesis around the outside of this? Probably not. But what I do want to do is I want to write this right now as a fraction. 24 to the negative 2 over what as I'm writing that? Got to write these, right? So what would we have as I'm writing that, Aaron? Over what? There's no denominator. 1 over 1. So now I got negative exponents again. Everybody, what do we do with negative exponents? Tell us to take the reciprocal. All right, so Wyatt, we're going to do the reciprocal. 1 over
24 over 24.
Negative 2, positive 2. Positive 2. Okay. Do I have to take my calculator out and do 24 to the second? No, because it said keep it as a power, right? So we're taking a look at that next one. Levi, we're going to add all of those together.
This is you answer the power. You want us to simplify it to 1/24 to the second, right? So maybe 24 to the negative.
Right. Can't have negative exponents. So no matter if we are keeping it as a power, that power has to be a positive exponent. Good question. Okay? So, all right, Riley, let's go to the next one. 9 to what exponent are we going to have when we start looking at that? So I got 6, right? Plus -4 plus -2. That's going to give me 9 to the, right, 6 plus -4 gives us how much? 2. And 2 plus a -2, 0. So if I'm looking at my answer, right, so I got 9 to the 0, what am I looking at? Cameron. My answer should be just 1 for that one. Does that make sense? 9 to the 0, not going to leave anything to the 0 because that's that simplified, okay? Just like yesterday in the homework questions, when you have something with, when I was looking at the homework, I had a lot of people not sure how they were simplifying this one. 8 divided by 4 is 2. And then you are moving around the m and the n. But this is 8 over 4 is 2 over 1. I was amazed yesterday in my algebra class. I had people telling me that when they have 3 over 6, that's in simplest form. And I'm like, so 8 over 4, 3 over, you can simplify those, and you have to do that when you see that word simplify. It means making sure it's in the simplest form possible. So in this one, when we see simplify, and we got a lot of stuff like this, first thing we're going to do is regroup, okay? So we're regrouping things. So as I start regrouping things, we're going to put the 4 times the 9, as we write down, and then z to the 5th, and z to the -12, okay? So Ashley, we're going to do some multiplying, and I get 4 times 9 gives me 30, how about 36? 36. And we're going to add our exponents, Jordan, and I get z to the 5 plus 12 is going to give me z to the negative how much? I just didn't hear you. -7, okay? So, I'm going to put this over 1, right? Because I got those negative exponents. Negative exponents tell us, everyone, to do the reciprocal. Do I take the reciprocal of 36, Patrick? Should I put that on the bottom too? Put the 36? No. It doesn't have a negative exponent, right? The only thing with the negative exponent is the z. So, 36 over, Patrick? Z to the 7. Okay? So, when you're doing your homework tonight, you're going to see problems like this. You want to show all of this work. You need to write this down, especially for the first few. Now, some of them are going to be really simple, but some of those later ones in the homework, they get really ugly, okay? So, Sam, let's take a look at the next one. Let's tell me what to write. We want to regroup it, putting like things together. So we're going to put all of our numbers, then all of our variables that are the same. Go. 2 times what? Okay, I want to get all the numbers. So I'm going to put 2, then I'm going to put 9, and then I'm going to put 3. Then I'm going to put a and a to the what? A to the second. And then I only have 1 b to the 4th. So Rowan, we're going to do some multiplying. If you guys need your calculators, take your calculators out, right? So we are going to take 2 times 9 times 3, which when I multiply that gives me, yeah. All right, thank you. We got 54 back here. Everyone else, take your calculator out if you need those. Then, if I'm looking then, a to what power? A to the 3rd. Remember, if there's no exponent here, 1 plus 2 gives us a to the 3rd and b to the 4th. And this is my answer. So when you're on your homework, one of the things I will suggest is that you either at the end put a box around what your answer is or put a circle around it, because you're going to have a lot of other stuff written there. Some of you guys write stuff all over it. It is really hard for me to keep track of your work even on quizzes. So we're going to look at this next one. Abby, help us out. Regrouping. So 4 times 2, and then t to the, yep. So I'm going to have 8, and Olivia, I'm going to have t to what power? Negative. What are we doing with those two numbers? Adding them. So -5 plus -3. -8. This is where on Dreambox, when I was telling some of you that yes, you could work on exponents, but integers, if you don't understand integer rules, this is making sure when you add those two negatives, like the temperature they say, you know, is going to be this next week, going lower and lower and lower as we think about that, right? So we now have this problem. So as we are simplifying, Caitlin. Nice job. Reciprocal only for this one. And if it helps you to circle and like, oh, something like this as you're doing your work, put that. The 8 has a positive 1 as an exponent, okay? So, Levi, we're going to look at this next one, and we want to write all of our, regroup it again as we are doing that. So, help me out, start us.
Negative 4 times, or negative 4.
Yep, just negative 4.
Negative 4 times 7 times 2.
Yep. And then we are going to continue as we are writing that, Sam, with what else? Okay, c to what power? C to the third, and then c to the negative 2, and then we got d to the second. All right, so Rowan, we're going to do some multiplying. 4 times 7 times 2 as we're doing that multiplying, we're going to end up with negative 56. As we are looking at our exponents, as I'm adding those together, Nolan, what am I going to get for my exponent of c? So I have c to the third, and I also have, if I'm looking at that, c to the negative 2, right? So I want to add both of those. So this might be the step for some of you where you put 3 plus negative 2, or Nolan, I'm going to get c to the first. Aaron, what about D? Do I need to change that, or am I adding it with anything? No. So just D to the second. Do I have to move anything? Do I have any negative exponents?
No.
I have negative 56. Shouldn't I move that to the denominator?
No, because it doesn't have a negative.
Doesn't have a negative exponent. Thank you very much. So hopefully you guys won't make that mistake when we're doing them on our homework and our quizzes. So Wyatt, let's tell us what we're going to write to regroup this. So in your homework, I don't want you just putting a bunch of stuff in your calculator. I want you to show me this step first. So, 5 times 3
times 3 x 5 x over 6 2.
Okay, does that make sense? I want to group my x's together. So after I put all my numbers, then I want to group and look, oh, now I'm going to put my x's. I would not suggest crossing them off. Maybe I do something underneath, like, okay, I wrote down all 3 of these. Now I got to make sure, okay, I did my x's. And then the last thing would be y to the 6 as I'm looking at it, okay? So, Luton, we're going to multiply. 5 times 3 times 3. 45. Next, Cameron, we're going to be looking at our x's. We're going to have x to the... Okay, tell me, what are we doing with our exponents? Because we are doing what with them? Adding. So, 2 positives, we're adding those. And if I'm putting down Riley, what? Yes. This is my answer, right? Don't have to change anything. So these 2, I'm going to circle those for my answers. I do not have to move anything as I'm taking a look at that, right? So in your homework tonight, I'm going to have you, if you would please turn back to page 41. 10 to the second. We are adding those exponents and getting what? So they already have the base 10. You just have to write the number 9. Write it big enough so that I can see it. Didn't know all right, I got to be able to see it. So this one, when you get to number 5, we want to rewrite it. You're going to show your work. The 7 times negative 3. Why am I putting negative 3 in a parenthesis? Because I'm taking it times 7, and I want to make sure I multiply positive times a negative to get that, right? And then I'm going to put a to the negative 1 times a to the 5th. And this is how I'm going to kind of show my work as I'm doing it. I just want you to notice, some of them get really ugly, right? Some have negative exponents. Do you do the same thing down here in the denominator with adding the exponents? Yeah, you do the same exact thing. So when I look at number 12, I'm going to have n, and I'm taking negative 9 plus 2 to get that answer. Negative 8, sorry. Negative 8, and is it a 3? I think it is a 3. And 3. So negative 8 plus 3. Which one is negative 8 plus 3? Negative plus a positive, it shouldn't be negative 11, it should be negative 5. Do you think I'm going to accept this answer on a quiz with a negative exponent? Negative exponents mean take the reciprocal, okay? So when you're thinking about doing